Okay, so today is a new subtopic and new chapter. Actually, it's a thermodynamic chapter 14. So 14.1, first law of thermodynamics. So state first law of thermodynamics. What is thermodynamics? It's a study of the system involving energy in the form of heat and work. In a closed system, a system whose mass remain constant but the energy is allowed to increase or decrease. So we have two ways of energy transfer, which are heat, energy transfer due to the temperature difference, and the other one is work. It's energy transfer as a result of force. Therefore, any system can exchange energy with its surrounding in two general ways as heat or work. Okay, so in chapter 13, you have already learned and defined what is internal energy of the system as the total of kinetic energy and the potential energy of all particles in the system, when given by equation of internal energy U is equal to degree of freedom is divided by 2 and RT. This is what we call as internal energy. We would expect that the internal energy of the system would be increased if work was done on the system. Or similarly, the internal energy would be decreased if heat flow out of the system. So based on this statement, they said that the first law of thermodynamics, that the change in internal energy of a closed system, delta U, will be equal to the energy added to the system minus the work done by the system. So mathematically, we can rewrite equation of first law thermodynamics as delta U is equal to Q minus W, where delta U is the change in internal energy, Q is the energy added into the system, and W is the work done by the system. Now, the first law of thermodynamics is a law of conservation of energy. Okay, this is a very important part. It's a sign convention. We must be careful in this sign because the Q and the W, they have their own meaning. Okay, because W in equation above is the work done by the system, then if the work done on the system, W will be negative and delta U will be increased. Similarly, when the Q is positive for heat added into the system, so if heat leave the system, so Q is negative. Okay, so this is surrounding and the system. So when heat out of the system, Q is negative. You have to put sign negative Q. When the heat into the system, so the sign of the heat, Q is positive. Okay, how about the work done? Okay, work done on the system is being compressed, so W will be negative. If work done by the system, when the gas is being expanded, so work done is positive. So let's say the system is a gas. So when the gas we put in the piston, okay. So when the gas is expanded by itself, so they can do their own work. So work done by the system or work done by the gas being expanded, so W will be positive. So let's say we compress the gas, the system. So work done on the system is that being compressed. So W will be negative. Okay, now we have an example. You are given three situations as follow. First, a system absorbs 2,100 joule of heat and at the same time does 1,200 joule of work. Means that the system absorb, means that the Q is positive. And at the same time, the system absorb 1,200 joule of work done. Okay, so means that the sign of work done here is also positive. So based on the thermodynamic equation, delta U is equal to Q minus W. So substitute the value, we get that the change in internal energy of the system is 900 joule. Okay, next question B. The system is absorb 1,250 joule of heat, positive Q, and at the same time 420 joule of work is done on the system. when the work done on the system, so the work done here, it should be negative. So based on the formula of thermodynamic, delta U is equal to Q minus W. Substitute the value of Q is positive 1250 minus with work done is negative because work is done on the system. Means that the gas being compressed. Okay, here. Work done on the system, so W will be negative sign. Okay, so the answer will be 1607 joule. Okay, next C, we have 5000 joule. Heat is removed from the system held at a constant volume. So 500 joule heat is removed, so means that here is heat removed, Q will be negative. So held at constant volume, what will happen to work done? Constant volume, we can set that the W is equal to P delta V. Yang ni kita akan tengok nanti. Okay, so as you know that W ni adalah kosong lah because dia adalah constant volume. Bila constant volume means that dia tak wujud changing lah. Changing akan dia kosong. So work done adalah kosong. So delta U is equal to Q minus W. So negative 5000 minus 0. Why negative 5000? Because the heat was removed. Okay, so delta U is equal to negative 5000 joule. Okay, change in internal energy. The change in internal energy is, we call it as delta U. For a system during any thermodynamic process is, we call as independent of path. For example, the thermodynamic system goes from state 1 to state 2 as shown in figure below. So as you can see, when the gas, or we call it the process of thermodynamic from state 1 to state 2, also we can call it as the internal energy. Change in internal energy from 1 to 2 is also equal to the internal energy, change of internal energy of the process 1 to 4, 4 to 2. Okay, also you can write as change of internal energy for 1 to 3, 3 to 2. Okay, macam tu. Tapi nampak nak panah dia? Okay, dia macam ni. So, ni adalah punya change in internal energy. Okay, so the internal energy depends only on temperature of the system. So, as you can see that the formula of change in internal energy is delta U is equal to F over 2 and R, so change in temperature. Kalau temperature dia tak ada perubahan, maka internal energy, dia punya change of internal energy adalah kosong. Okay, if the initial and final temperature of the system is the same, so we know that delta U initial is equal to U final. So kita tahulah change in internal energy adalah kosong. So the change in internal energy also zero in the cyclic thermodynamic process, what we call in closed cycle. Maksudnya closed cycle means kita boleh consider sebagai macam ni lah kot. In the cyclic thermodynamic. Okay. So cyclic thermodynamic maksud macam ni. Dia back to original position. Okay.